So today we will discuss about the Snowflake architecture. Yeah. So in Snowflake architecture, we have a three layers. One is cloud service layer, another one is query processing layer, another one is data storage layer. So we have these three layers in the in the Snowflake architecture. We will discuss one by one. What is a database storage layer? Database storage layer is the layer where when we load the data into the Snowflake, directly the data will be stored into this layer, and that data will be stored in the Snowflake. That is in a list storage component that is called micropartitions. Micropartition is the storage component in the Snowflake where we load the data. Initially, where we load the data into the Snowflake tables. Internally, that data will be stored into the multiple continuous micropartitions. Each micropartition size will be the 500 MB. So when you load the data into the tables based on the your data value, so those many number of micropartitions will be allocated to your data. Whenever the data is loaded into the micropartitions, whenever the number of micropartitions are allocated to the your data, that metadata will be stored into the metadata tables in the Snowflake. Suppose you have a customer table, you have loaded the data into the customer table. Around 10 micropartitions are allocated to your customer table data. So that how many records are available in the each micropartitions, what are the micropartition number. So all this metadata information will be loaded into the and stored into the metadata tables. So this whenever the metadata information is available in the metadata tables, while reading a data, this metadata information will be used. That I will tell you. Once again. See, this is the micropartition. Whenever we load the data into the table in the Snowflake, that data will be loaded into the continuous micropartitions. Here we have a micropartition 1, micropartition 2, micropartition 3, and then micropartition 4. We loaded the data into this table. When we load the data into the tables in the Snowflake, default or else in the internal, the data will be stored into the micropartitions. And also data will be stored in a Snowflake in a column format, not into regular columns and then rows format. The data will be stored into the column format. when the data is stored into a column format, we have an advantage that I will tell you what is the advantage. And also, the data will be stored in a compressed format in the Snowflake. Compressed format means what? Suppose let's consider if you load the 1 GB of data into your table, whenever the data is compressed, always the storage location will be occupied comparing to the less than space comparing to your original data. Suppose if you load the 1 GB of data into the table, maybe it may be take around 900 MB or 950 MB. So if you save the at least 100 MB, then it will be the good save. So if you save the storage space, if you save the storage space, then you are saving cost to your organization, because the cost will be calculated on the Snowflake. So based on your storage location, utilization and your hardware resource utilization. That pricing part we will discuss later. So now, what is the benefit? What is the benefit? What is the benefit when we load the data into when the data is going to store into the micro partitions? See, this entire data is loaded into these four micro partition components. These four micro partition components. Fine. Then suppose when you query a data to read the data from this table where name equal to y, y is available in the two places. If you query this table where name equal to y, select star from the table where name equal to y, the micro partition 3 and 4, the y values are available here. By using a metadata information, directly it will come into the micro partition 3 and then micro partition 4. Instead of reading all the micro partitions to read the specific data or a particular data, directly it will come into the micro partition 3 and then micro partition 4, and then we have two rows in a micro partition 3 and then micro partition 4. Then it will bring the data for you from the micro partition 3 and then 4. What is the benefit here? To read the directly a particular micro partitions here. Suppose let's consider we have here only 4 micro partitions and the limited data. Let us consider if we have a terabytes of data into your table, and then so n number of micro partitions are allocated to your table. So in that scenario, if while reading a data from the table, if the n number of micro partitions are allocated, while reading a data from the particular table, if n number of suppose 1 TB of data, so how many micro partitions? Divide 500 MB. That calculations maybe suppose how many micro partitions will be allocated, guys? 1 TB of data means 124 GB of data. For 1 GB, there will be around 3 micro partitions. For 1000 GB, 3000 micro partitions, more than 3000 micro partitions. If the data is available in the more than 3000 micro partitions, while reading a data, suppose if while reading a specific records from this table, if 3000 micro partitions are scanned and then bring the data from the specific micro partitions, then it will cause a performance issue, because if the data is available in the only in 10 micro partitions, but to read the data from the 10 micro partition, if it is scanning entire micro partition means that will cause a performance issue. So that to avoid that, what Snowflake, what Snow, what Snowflake has designed, instead of scanning a enter micro partition, by enter micro partitions, by using a metadata information, directly it will come into the particular micro partitions, and then it will bring the data for you. So by doing this, always we will see the very good performance improvement and very good performance optimization while reading a data from the Snowflake. So that is the one advantage. What is the advantage? What is the advantage if the data is going to store in a column format? See here, when the data is going to store in a regular rows and column, then data will be splitted like this. First record will split first record, and then second record will be split into multiple micro partitions. If you read, if you want to read if you want to read a single record also, that record will be split across multiple micro partitions. To read the one record also, you need to touch multiple micro partitions. To avoid that, the data is going to store in a column format. Suppose see here, if you want to read the first record is available in this place, in this type is 2A UK and then 11 bar 2, 2A UK and then 11 bar 2, 11 bar 2. So if you want to read the first record, then directly it will come into the first micro partition, and then it will bring the data for you. As data is available in the only first record is available in the for only one micro partition, so that it will scan only one micro partition. It will not trust the remaining 3 micro partitions. So that is advantage here. Suppose if the data is stored in a rows and then column format, if the first record is split across the multiple micro partitions, to read the one record also, it needs to read from the multiple micro partitions. Again, it will take time to scan the multiple micro partitions and bring the one record. Instead of doing that, if the data is available in a column format, directly it will go into the particular micro partition. If that record is available in the particular micro partition, and then it will bring the data for you. So that's how the scanning time is going to save. Scanning time is going to save, and then you can see the very good performance improvement in the. We can see the very good performance improvement in the Snowflake. So that's how the default, the architecture in the Snowflake they have designed in such a way that you can able to see the very good performance improvement in the all the tasks, very good performance improvement in the all the tasks. And also you may be heard about the indexes in the other RDBMS. Like that, we have a concept called here. We don't have index concept, but similar concept we have in the Snowflake that can be called as a clustering keys. If you create a clustering keys on the, see here, if you create a clustering key on a name column, clustering key, if you create a clustering key on a name column, fine. Again, physically the data will be sorted. Now, if you read select star from column where name equal to y, the y values are available here. If you come into the micro partition 4, the y values are sorted in a physical order. Earlier, the y values are available in the two micro partitions, micro partition 3 and then micro partition 4. Then it needs to scan two micro partitions. Now the data is sorted. The values are available in the values y are available in the micro partition 4. Then directly it will come into the micro partition 4, and then it will scan this micro partition, and then it will read the data, and then it will return the data to the end users. By doing this, again you are going to save the scanning of the multiple micro partitions. Directly it will come into the particular micro partition. Earlier, to read the data, select star from table where name equal to y. Earlier it has scanned two micro partitions. Now it is scanning only one micro partition. Again, still you are saving a scanning of the time of the micro partition. So by doing this, then you can able to save the scanning of the micro partitions, and you can able to read very quickly from the Snowflake. So that's how the Snowflake is going to store the data, and then almost all it will take care of the performance improvement of your operations, performance improvement of your operations. If you see here,
So Shekhar, how it is happening in the backend? If I talk about SQL Server, they maintain some RID, and then we have map table, and that's the reason row ID we are able to look it. But here, how it happen? How it get to know to which partition a record will be there?
that is what, see here, 1 second, see, micro partition 1, the rows 1 to 6 records are there. Micro partition 2, 7 to 12 records are there. Micro partition like that. So these information will be somewhere written into the metadata tables in the Snowflake. That metadata tables, everything I will share you later. Fine. So this table information and then this micro partitions information will be written into the tables. So from there, when you query a data from the table, then by using the metadata table information, then directly it will go into the particular boxes and then bring the data.
Understand. So then now my next question is how it is deciding like 5 rows will be in micro partition by one and next 5 will be in two. So is there is a something that we can define at the time of creating table or database that
No, no, no,
so
no.
and so number of records will be going in so and so
We will
partition?
we will not going to define. We will not going to define anything because the micro partition size will be the 500 MB. Fine. There will be allocation internally. How many micro partitions are allocated to the for the entire tables? So it will start to load the data into the next micro partitions based on your data value into your table. According to that, those many number of micro partitions will be those many number of micro partitions will be allocated to your data.
Okay, so is there is any chance of fragmentation, let's say internal and external fragmentation we used to see where data used to wipe across?
Yeah, see that fragmentation level, that's what, see, I understand your question, but yes, till now, till now, in my experience, I have not applied this compression technologies or fragmentation, those things and all in the Snowflake.
Okay. You mean internally they have mechanism and they are taking
But
care.
that's what.
Okay.
So this is about the your storage layer. 1 second. The database storage component of the Snowflake. 1 second. I will zoom it. When you load the data will be stored in a continuous micropartitions in a compressed and then optimized way. Size of each micropartitions will be 50 to 500 MB. Data will be stored in a column format. Same thing, whatever we have discussed. The both structured and then semi-structured data, you can able to store the data into your micropartitions and your database storage layer. This is about the storage. This is about the your database storage layer. Coming to the query processing layer. Query processing layer is the important here. See, whenever so this is the query processing layer is creating a virtual compute warehouses in the Snowflake. These virtual warehouses are hardware resource to your Snowflake environment. So these are the hardware resource to your Snowflake environment. How we are going to create a objects, like how we are going to create objects like tables, schema, database. Like that, we are going to create these virtual warehouses in the Snowflake. Without this virtual warehouses, without this, when I pronounce virtual warehouses, purely that is a hardware resources, hardware components. So there is no physical hardware component set up in the Snowflake. So this virtual warehouse is the hardware resources into the Snowflake. Fine. So without this virtual warehouse, we can't able to perform any task in the Snowflake. we can't able to load the data, we can't able to execute we can't able to execute any SQL components, we can't able to read the data. For everything, whatever you do, whatever the activity you perform in the Snowflake, for sure you need to use virtual warehouse. Then this virtual warehouses will be created with the different sizes. I will tell you, and you can able to create a multiple virtual warehouses in the projects. Suppose if you see the your on-prem, if you see the your on-prem servers, you define hardware resources, and then multiple projects will be utilized. Multiple projects will be utilized. Same hardware resources. I mean to say, hardware resources are shared across the multiple projects in the on-prem servers. Here in the Snowflake, there is no shared concept here. If you have a 20 projects or a 20 team, 20 projects or a 20 team in the organization, those 20 projects or 20 team are using those 20 projects or 20 teams are using your Snowflake environment. In such scenario, they will be creating a 20 virtual warehouses, and they will be use their own virtual warehouse. And also DBS will restrict that based on the user ID, you can able to see your own project related virtual warehouse. So instead of using a multiple virtual warehouses for your multiple warehouses for your project, whatever the virtual warehouses are created, virtual warehouse is created for your project. The virtual warehouse is created for your project. Then you need to use that virtual warehouse. And by default, the DBS they will restrict when you log in into the Snowflake account. Then according to your project, you can able to see your own project related virtual warehouses, so that there is no confusion. There is no you can utilize other projects related virtual warehouse into your projects. So based on the project requirements, you can able to define a multiple virtual warehouses, and then you can use your own project related virtual warehouse. And the virtual warehouses will be defined based on the different virtual warehouse sizes. Based on the different virtual warehouse sizes, I will tell you. So we have a one second, please. See here in virtual warehouse, so we have a different sizes. X small is one size, small is another size, medium is another size, large is another size. Fine, and then X large is another size, double X large is another size. So based on these sizes, you can able to create virtual warehouse. You can able to create the virtual warehouse based on the requirement. Suppose if one project may be will be having a so less number of users, and then they are connecting to your data warehouse, and other projects may be having a more number of users, and then they are communicating to your Snowflake environment. So in such scenario, based on the scenarios, projects will be different. Based on the scenarios, project will be defined. Project will be defined their own individual virtual warehouse, so that they can use their individual virtual warehouse. By doing this, we can able to see the very good performance improvement in the all the activities here. See, you are using your project one is going to use project one related virtual warehouse. Project two is going to use project two related virtual warehouse. There is no confusion here. There is no shared hardware resources here. And also, you can able to define while creating a virtual warehouses in two ways. Suppose once you define a virtual warehouse in the Snowflake, so based on the requirement, suppose in early morning, some data load operations are happening into the Snowflake. So based on the data load, all of the sudden, suppose on the fine morning, If you get the huge data, then your expected size. If you get the huge data, then expected size. Then expected size. Then if the task array, if the operation is taking too much of time to complete the particular task, in that scenario, you can manually intervention and then you can increase the your virtual warehouse size to complete the particular task within the timelines. While increasing your virtual warehouse size, you no need to stop any operations, and you no need to stop any operations. You no need to uh, like see, while upgrading from one virtual warehouse size to another virtual warehouse size, you no need to stop any request. Suppose if multiple users are submitted some IO request, multiple users are loading a data into the Snowflake environment. There are multiple requests are running into your Snowflake environment, but it is taking little bit time than expected time. In such scenario, you can able to increase the virtual warehouse size, but while doing this, you no need to stop any request. Parallel operations are executing. And then finishing their activities. So that is one of the very good advantages with the Snowflake virtual warehouse. Along with this, increasing the manually one virtual warehouse size to another virtual warehouse size, you can also define virtual warehouse sizes. You can also define virtual warehouse. You can also define virtual warehouses like, instead of manually increasing the virtual warehouse size, automatically it will increase its size. Automatically it should increase its size based on the requests are available in the queue. Suppose let's consider 100 users are concurrent users are submitting a request. Some 50 users are submitting in the data load process, etc. And around 20 people are generating a reports. 20 users are generating a reports on top of your Snowflake Cloud Data Warehouse. If the requests are more, and then the tasks are taking too much of time to complete within the time, so to complete within the expected time. So in that scenario, you have two ways. Either you can increase the manually, virtual warehouse size, or you can create this virtual warehouse to take care when the requests are more. Automatically the virtual warehouse size will be increased. You no need to manually intervention to increase the virtual warehouse size. So that is the beauty we have here. When you create a virtual warehouse, to take care automatically everything, then based on the number of requests are available in the pipeline, automatically it will calculate internally, and then it will increase its virtual warehouse. Automatically it will increase its virtual warehouse capacity, and then complete the task within the time. And also you have a option while creation of this virtual warehouses, like yesterday I told one point, scalability. Scalability means what? Whenever suppose you define, these are hardware resources. Whenever you complete the work in the Snowflake, and whenever you log off your system, and the Snowflake session is closed, you can able to define in the virtual warehouses, you can able to provide the particular time to suspend the session or to suspend this virtual warehouse. After continuously, if you are not using the session, suppose if you give the 10 minutes, if you give the 5 minutes, continuously if you are not using your session, if you are not using session for the 5 minutes or 10 minutes, if you define 5 minutes, then it will take the 5 minutes. If you define 10 minutes, it will take the 10 minutes. After completion of log of your Snowflake, if you are not using continuously for the 10 minutes, automatically the session is going to into the suspension mode. Whenever it is going to into the suspension mode, then you are saving a cost to your organization. Nothing but Snowflake will stop to cost to your organization when the sessions are into the suspension mode. So that is one of the advantages we have here. In traditional data warehouses, whether we are using, whether we are not using, always the servers are in a up and run. Here not like that. if n number of users are connecting to your Snowflake environment, and n number of users are using your Snowflake environment, and whenever they are completed their work, if they are done with their work and then they are closing the sessions, whenever they have closed, after completion of the defined the particular period, the sessions will be going into the suspension mode. Whenever the sessions are going into the suspension mode, the Snowflake will not charge on your Snowflake utilization. Snowflake utilization. So that's how, suppose let's consider, that's how the scalability, and then 1 second. Yesterday we seen that one word, convenient pricing. Convenient pricing. Convenient pricing. So by doing this, so you can even see whenever we are working, we need to work. Whenever we are not working, then why do we waste the resources and then cost? So that is a benefit and then option this Snowflake has given. And then whenever you restart into the session, and nothing but whenever you log in into the session, automatically it will resume its activities or its services, or the session will be restarted. So this is about your hardware resources discussion, virtual warehouse discussion. 1 second.
So Shekhar, so what I can understand is, I mean, when you are mentioning resources, do you mean the RAM or
Correct. Internally, whatever we were defining into the in a traditional data warehouse, when you create the virtual warehouse in the Snowflake, by default it will perform like a hardware resources. But here just we will create the virtual warehouses as like a object.
It's a kind of separate system, right? Individual systems.
Sorry.
Like warehouse is nothing but separate individual systems, right?
No, I am
Which have their
talking.
own RAMs and all, right?
No, I am talking about the virtual warehouse, not in a warehouse here. That is a confusion. Virtual warehouse nothing but a hardware resources.
That's what I'm telling. It's like a separate system, I'm telling.
Separate system means?
Kind of computers, right?
No. Not in a separate systems. I am telling the word the same like objects. Same like objects. See, we have a multiple virtual warehouses here. Then we are going to create these virtual warehouses in the Snowflake. I will show you all these things and then options while once we create our Snowflake account, then there how we can create this virtual warehouse, and then what are the options are available in this virtual warehouses, how we are going to utilize that virtual warehouse and all. I will show you once the account is created. Maybe at this stage it may be getting a confusion without seeing the things, but still yes, we don't have other options. Maybe by tomorrow we will create our Snowflake free trial version account. So there we can explore all the options, what are the options are available at the time. Then I will show you this. I will show you all how do we create the virtual warehouses, and then what are the options are available. So those things are by, if you see those things are done, then you may be getting the clarity on that. So at this stage, maybe you get the confusion, but for the high level, this is not any physical component. This is like a object. You are going to create, how you are going to create a table and then schema database, like that only you are going to create your virtual warehouse.
so
So
Shekhar, I mean, it looks like whatever memory we need to do temp DB storage, or let's say login, or let's say SQL plans, and any metadata related temporary storage what Snowflake is required, maybe that is getting stored under different virtual warehouses based on the logins and access privileges. So that's what I can understand and think.
that's fine now, Sandeep. Guys, next will be the cloud service layer. Next will be the cloud service layer. So cloud service layer is the topmost layer in the snowflake, and then which is the important layer in the snowflake. I will tell you why this is the topmost and then important layer in the snowflake means. See, whenever the users are trying to connect into the snowflake environment, the very first level, the valid user or not, and then what type of privileges that particular users are having, those kind of information, those kind of checks will be done with the cloud service layer only. Authentication and then access, those kind of checks will be done with the your cloud service layer only. See, we have a suppose around 100 users. 100 users are accessing your Snowflake account, and they are performing their activities in the Snowflake. So based on the roles, and then based on the user, what kind of privileges he has, what kind of operations he can able to do. All these things are taken care by this cloud service layer only. In the very first step, whenever you log in into the Snowflake, that that user level checks are done should be gone through this cloud service layer only. Whether the valid user or not, what kind of privileges that user is having, and what kind of operations he can do based on the privileges. All those things will be performed by your cloud service layer. All those things will be performed by your cloud service layer. So that is the one point. The second point is whenever the end users are submitting, to the end users are submitting a IO request to the your cloud service layer, the very first step, and then that IO request should be go through the your cloud service layer only. Because whenever, suppose let's consider I am one of the user, I am submitting a SQL code to read the data from the Snowflake environment. Whenever I started executing the SQL statement, internally it should go through the cloud service layer, and then it will parse the entire your SQL statement. If your SQL statement is valid, then it will pass into the next level. Nothing but a parsing. What is the meaning of parsing? If the syntactically your submitted SQL is correct or not, and then mentioned objects are available or not, everything it is passed by your cloud service layer. If everything is fine, then only it will pass into the next level to bring the data. If everything is fine, your submitted queries, everything is fine. If the cross check, your cloud service layer has cross checked, and then the submitted code is fine, then it will submit into the query processing layer. It will submit into the query processing layer, because in this query processing layer, then we will be having a memory cache here. We will be having a memory cache here. In this memory cache, almost previously query executed results are available in the cache memory. For that particular submitted query, if the results are available in the cache memory, then it will take that existing result, and then it will submit into the cloud service layer. This cloud service layer will submit into the end user. So that is the meaning. Whenever you submit a particular query, the end-to-end will take care of the cloud service layer only. It will receive your IO request, and then this cloud service will return the data to the end user. It will take care end-to-end. It will receive the request, and then it will check, and then if everything is fine, and then it will send it to the next level, and then it will take or receive the data from the query processing layer or database storage layer, and then it will return the data to the end users. What if the data is not available in the cache memory? Then again, then the request will go into the database storage layer, where your actual data is stored in your Snowflake. So from there, it will bring the data and then submit it to the cloud service layer. This cloud service will be a layer. Again, it will return the data to the end user. End to end, it will take care. Again, this is one of the important role of the cloud service layer. See, whenever we load the data into the Snowflake environment, fine. Whenever we load the data into the Snowflake environment, if entire the data is stored into the Snowflake environment, and then it will commit all those transactions or all those records into the your Snowflake environment. If while doing a operation, due to some XYZ reason, the session is stopped. Nothing but half of the data is inserted, half of the data is not inserted. In this case, this is not any meaningful data because you are inserting some set of records into your table. But while inserting a data into the table, if you are inserting entire records, then those are a meaningful records. If you insert a partially data into the tables, and then due to some XYZ reason, your session is stopped, and then if the session is stopped and the remaining records are not inserted into your table, then in such scenario, whatever the data inserted, that is not meaningful. So this cloud service layer will take like if the data is all the records, all the data is stored into your tables, then it will commit all the data. Or else, as I mentioned, if the data is not inserted completely, if the data is not inserted completely, then it will roll back all the records into from the table. Because if the data is inserted, partially data is inserted, then it is not meaningful. So all these kind of things will be taken care by this cloud service layer. And then whatever I mentioned, the metadata tables, those things those metadata tables will be handled and then maintained by this cloud service layer. So this is like high level details about the architecture. One second. Where is that? Yeah. So this is the top layer. Without this, Snowflake will not work. Once you submit a query will be parsed from this layer and will submit to the storage layer, and then cloud service will return the data. So this cloud service will take care of the end to end. It will receive the end to end. It will receive the data and then it will submit the data to the end users. So this is about your Snowflake architecture, guys. Now you can ask if you have any questions.
No, Shekhar, I think things are pretty much clear. So I think in query processing, if we are querying to particular table again and again, maybe that data is getting stored in cache so that when next time similar type of query comes in, so data will be sitting in that virtual warehouse. That way it will be returning faster to the basically source clients, because it will not go to physical storage as such. That's the one thing. And then about this cloud services, just one question I do have in my mind is how high availability is being taken care. Let's say if something goes down, how is there is any master slave kind of thing where particular things goes down that's way, because when we are
Yes. Yeah, we have some high availability concept in the Snowflake, but in that level, I can say frankly, I don't have commanding on that. Because see, this system is even Snowflake we are using from last 2 to 3 years. But yes, if you say about the other odd EVMs, those things and all, we have a robust experience. We can talk in detail like anything. But we are using from last 2 to 3 years. Yes, I understand your question, but we need to look into that how this uh, high availability concepts are working here. I will check that point and then get back to you, Sandeep.
thanks.
And then tomorrow, so we will create our own Snowflake free trial version account, and then from there we can explore what are the options are available and what are the regular options we are going to use. and then how your Snowflake UI looks like, and how do we execute some sample code, how do we execute some, how do we create some sample or simple objects, XYZ we will going to see by tomorrow. If you have any questions in today's session, then in today's and yesterday's session, you can ask me, guys. And maybe actually I got a message from the institute that they are going to allow 3 free demo sessions. After completion of the 3 demo sessions, they may change the link. You need to get the registration with the people. Guys, any doubts in today's discussion? Sandeep has shooted number of questions, and I didn't get any questions from others like Madhavi, Mallikarjun, Sanjay, Srinivas. If you have any questions, ask me, or else we'll close the session and we will continue by tomorrow at same 5:30 AM. Guys, if you don't have any questions, just say no, then we can close the session and then we will continue tomorrow.
To my side, no.
Others? Hello guys, then we will close the session and then have a nice day. Thank you. We will meet tomorrow, guys.
Thank you.
Yeah, thank you guys. Bye bye.